Hello, this is Paul from Foresight Tech. In this lecture, we are going to deal with the derivative given conditions. And let's see the material. And in this video, we only go to two questions together. Okay. So first, what does given condition? Okay, and usually, like given conditions, give you the derivative values. Okay, for example, in the first questions, we know the value of the function at 1. We know the derivative of the function at 1. Okay, this is the given condition. And we use this and then going to find the derivative they ask. And what kind of information we do need, which is just the product rule and the quotient rule, because that's the two major rules so far we used, right? So a lot. And for example, here the first, can we see, given the condition, and the question is going to find the derivative of this big function. And as you know, the function is the product of two functions, right? And then what do we do? Here is find the derivative at x equals 1. Okay, this type of questions, all we need to do is to deal with, to pay attention to the notation. What does this mean? This notation is Leibniz notation of derivative, right? And this is bar, which means given x equals 1, which means find the derivative at x equals 1. Okay, so what do? We have just to find the derivative first, which is the first step. And then plug x equals 1 into the derivative function. That's the second step. And then we get the answer. Okay, so let's move on this question. You can see. So which rule to use first? Is a quotient rule or product rule, or determined by here, the function. And this function is a product, right? Okay. Therefore, you know, what do? We have to use the product rule, definitely. So the product rule is the one we need to use. Let's going to see the product rule. Okay. D and the dx is the differentiation operator. Okay. So it's just like prime. So this is the Leibniz notation. And you can use Leibniz notation. I use prime, okay, so because the formula looks a little easier, I use the prime. Okay, what is the function? X squared times fx, and this is the function. I will going to find the derivative function first. What is the derivative function? Okay, this is the product rule, right? Okay, we have two. We just use the product formula, which is the first term take a derivative. The square take a derivative times f, right? And then what? Plus the first term times the second term take a derivative, which means the second term take a derivative. Can you see this is the product rule? Okay, so let me going to simplify a little. Because x squared is the power, take a derivative, which is 2x, right? And then this is all we can do so far, right? So we already get everything put here. Then now, what do we do? So this is what is the derivative function. What the question? The questions ask find the derivative at x equals 1. So now let me copy the question. All we need to do is find the d and the dx. This is the derivative. Okay, so this is the formula. This is the function. Let me find. We already find this, right? The first prime is equal to this. And then what? Then add x equals 1. X equals, let me highlight the 1. Okay, so because this 1 is the point. Okay, so we need to plug into the derivative function. And we plug this 1. So can you see? We plug this 1 into the derivative function. And then we can calculate the value. That's all we need to do, the second step. Now. And we do this, we plug. So the first is 2 times 1, right? So 2 times 1, 1, I use this, I use the parentheses. Okay, 2 times 1, right? And then what? And then is f at 1. Okay, f at 1. Okay, and then see, we just plug 1 into 1 square into the derivative function. So that's 1 square. And then times the derivative at 1. All we need is just do this, evaluate. I think you know how to evaluate, right? Now what? 2 times 1 is 2. F1 is 3. See, that's the given condition. One of the given condition. So times 3, right? And plus 1 squared is 1. And the derivative at 1 is -1. See, another condition per log. -1. And then 6 minus 1 is 5. Okay, so here is the first question. We get the answer. Then you see we use the product rule, right? So we go 2 steps. The first step, find the derivative function. Always do like this. The second step, plug into the number, which is x at, right? Plug into the number into the derivative function. One more questions. You look at this. You see what the difference. We have a given condition, right? And the question is still the similar. Going to find the derivative function at x equals a number. Okay, all the difference is here. And this time the function is a quotient. Can we see? That's a quotient. Okay, therefore this time what are we going to use? We have to use the quotient rule, right? We have to use a quotient rule instead of product rule. Okay, so I will going to use the quotient rule now. Okay, and h x over x going to take a derivative. Okay, I will going to take derivative, and I plug into the formula first. Remember the formula. Okay, the bottom is the bottom square, which is x square. What's the top? You remember the top, right? So here the middle should be minus. The first is what? Is the first take a derivative, which is h take a derivative times the bottom, and then times x. Can you see? This is the first term. The second term is the first, which is x, hx, times the denominator take a derivative. Okay, so I ignore. Why? Because x take a derivative is what? Is 1. So hx times 1 is still x, right? So let me see. This should be what? This should be times 1. Okay, times 1 we just ignore. Okay, we can do this. We ignore this. We ignore the times 1. Oops, sorry. And then I put this is what we get, right? The first step. We can always simplify, just leave it here, which means we already find the derivative function. That's the first step. The second step is just plug 2, x at 2, right, into this derivative function. Okay, so the second step is going to do this. Okay, this is the derivative at hx over x. Okay, that's the derivative function which we already get. And then focusing on at x equals 2, which means what? That means they are highlighted the 2. So I highlighted the 2 to here. Remember, all we need to do now, plug 2 into the derivative functions. Okay, I will going to plug in. See, after we plug, what do we get? So 2 square is the bottom, right? The bottom is 2 square. Okay, the top is h, take a derivative at x, which is at 2. Times x is times 2, right? Okay, now is minus. Okay, we know the minus, so minus h at x, which is 2. Okay, good. So this we plug everything in. Now what do we do? Do calculation, right? Okay, so we're going to do calculation. The last, what do we get? So I plug in, the denominator is 4. H derivative of h at 2, which is the condition -3. So I plug -3, right, times 2 minus h at 2, which is 4. That's the condition. And then you do calculation, see what do you get? Negative 10 over 4, which is 5 over 2. That's the answer. Can you see this question is very similar as the first question, right? Okay, so that's all. Thank you. If you have any questions about this topic, please leave your questions on the comment. If you like this video, please subscribe to my channel for more videos. In the next video, what we are going to do, you can see. Okay, so we are going to deal with the trigonometric limits. Okay, like this is the most important formula, which is the foundation for derivatives of trig functions. I will going to see you next time. Thank you. Have a nice day. Bye.